3D printers that we have acquired here at Road State College. One's more of a deluxe model, and the other are just smaller models that help students get introduced into the level of 3D printer. And then as they get more advanced into the studies, then they can use the bigger model of the 3D printer. That's something that we're considering offering within the consortium, is access to the 3D printer. If they would like, we would just charge them minimal for the labor and just material costs. But if they had a short-term need to try something out, they can hire us out. Right now, it's not so much the material, it's just finding somebody who would have the time and the flexibility to do that. The company would be asked to submit their plans, and then as long as it's compatible with our computer system, plug it in and then let it go to work. And when we say we would charge them minimal labor, it'd actually be for the actual hands-on work. It wouldn't be, if it took 8 hours to produce that thing, we wouldn't charge them 8 hours. It would just be for the actual time of programming the printer to put out the product.
Doug, can I jump in real quick?
Yeah.
Do any of the schools have 3D printers currently? So really, you guys don't. But what I was going to say is, I currently teach a SEED program it's through Opportunity School and Sydney High School, but they own a 3D printer. It's actually owned by the Midwest Regional ESC, so everybody would have access to it. It's pretty portable that I could actually bring it out and we could make that a part of each one of these at each site. I know two of you said you do already, but if you want that as an option, that is something we could bring out. We have plenty of filament, plenty of stuff that we could add that into some of what we're talking about here. That is an option because it's already purchased. There's plenty there we could make a lot of different things with it. It's a little finicky right now. They're doing a new nozzle that's supposed to be much improved, but it's on back order right now because they've had so many people order them. But that is an option that we can use because I use it currently at Sydney. I teach kind of a manufacturing class right now, and I use it in there for prototype design and things like that. So that is an option. I wanted to make sure that everybody knew what's available. So.
Yeah, it's going to be kind of like what PCs are today. 20 years ago, you probably never thought you'd have a computer in your home. Now, how do you live without one? And, it might be such a thing that you produce your own little products in your own home with a 3D printer. They're talking about, I think they actually do have them out. They actually produce food products with a 3D printer.
Pancakes.
Yeah.
Two real quick things. Yesterday there was a news story. There's a young man in Florida, 8th grader, who's coming up with a prototype, and he's doing it with lowering the cost. He's using wood. He's using laser cutter and using wood to construct the basic frame of it and some other things to lower the cost of the 3D printer, and he plans to market it. That's an 8th grader. My daughter teaches 4th grade in Owensboro, Kentucky, and she has one in her classroom. And it was through a grant she got for introduction of STEM to 4th graders. And they actually have to design a train that operates on the computer and some other stuff. We were doing that several years ago at the high school level, and the 4th graders are now doing that. And she got that through a grant with Toyota. And they actually sent the engineers to work with her to teach the children. It was really a cool thing. And she said they come up with all kinds of stuff.
And there's a lot of new design softwares out there. Some of them are even web-based. Like we use Chromebooks a lot at Sydney, and there's a couple that are completely web-based that can be used on Chromebooks. Like one of them is called Tinkercad. That's one that we use in the classroom. But there's a couple others like that where you don't even have to teach them in-depth CAD for them to be able to put simple shapes together and create something that they can then in turn print on the 3D printer. So.
No, again, we had some flexibility built into the 40 hours. If there is some time, this can be a time-consuming process, but if there is some merit to maybe incorporating this within the 40 hours, go ahead. And like I said, it's becoming a very, very common skill for people in manufacturing, or get your foot in the door in a lot of schools if you want to pursue post-secondary education, because AutoCAD, 3D printing, it's a big part of just about any program here in engineering. Just some stages of production, design and development. You see some ideas there. Prototype car on the right-hand side. I've got a niece who's engaged to an engineer at Honda, and he's driving a prototype car from Honda right now, and just driving it around, giving it his comments and observations on it, and it's scheduled to be released onto the market sometime in 2017. Another stage of production, actual producing the product. That's where you set up, operate, and monitor the production, and then you manage your resources, such as your labor, capital, machinery, and information. That's a part that students, we test their knowledge on too. When we say production resources, have an understanding of what those are. And when we say production resources, if you're to start a business from scratch, what are the foundational things you would need? You need building, technology, energy, labor, information, things along that line. And then also controlling your production. Once you get your system up and running, making sure you're producing quality products within specifications. Some other stages of production, packaging and distribution. Again, becoming increasingly important. Things are getting more sophisticated in how you distribute and package your products. We're just sitting in ground zero right here in Lima, just up the road with Procter & Gamble. They've got that state-of-the-art distribution center just to the east of us off of Cool Road. Has anybody ever been in that? A couple of you have. If you want to see state-of-the-art in packaging and distribution, that's it. I mean, it's what they say is about the size of 10 football fields. And it's actually kind of a building inside the building. You have the shell to house everything, but inside it's a framework, and you just hear all kinds of activities. And what this is just computerization, moving pallets of product around, and it's moving it in a timely manner so that when it is time for this to be loaded onto the semi, it will be at this specific place at this specific time. But in the meantime, you just hear this buzzing of activity of pallets of product getting moved around and shuffled. And you've got unmanned forklifts going around too. You got to kind of watch yourself there. But if you want to see something into the future as far as automation and packaging, if you can set up a tour of that plant, it'd be worth your while. It's very fascinating. I think I toured that about 5 years ago. And you said you did too, Aubrey?
Yeah, when we first moved here, we had a chance to go see it.
Stages of the product. That's where you set up, operate, and monitor production. That's another stage. And you manage your production resources. There used to be a time when you just indiscriminately bought your product that you produce with, and you just indiscriminately disposed of it. In today's age of lean manufacturing, it's just-in-time delivery. You buy what you need when you need it, and you dispose of the scrap material. When we were touring Randall Bearings just last fall, they're just a little bit west of the Lima refinery, but they produce things out of bronze. About any kind of metallic material is very, very expensive these days, but you can about imagine what the price of bronze would be. But they make a lot of different fittings for companies. I know Halliburton's one of their big contractors, Caterpillar, Crown Equipment, but make a lot of things out of bronze, and you see bins and bins of scrap bronze, from machining into the finished product, but you've got, bins full of bronze, and that stuff is very, very valuable. There was a time when you probably just would have thrown it away, but now you've got a market for that. Dick Rapp, who president of Gasdorf, same thing. They produce primarily things out of iron, steel, things along that line. He said, we used to pay to dispose of this material. Now we've got people who buy it off of us, for recycling purposes. So another production resource is managing your resources, even down to the scrap. 8 production resources. I think I touched on them just a minute ago. Labor and management, that's one. You need people to produce things. Materials, that could be your raw materials for producing your product. They can come in any different form. They can be plastics, metals, powders, liquids. Tools and equipment, that's another production resource. Your actual building, your facility where you produce, that is a production resource. And this is kind of hard to get your head wrapped around, but time is actually a production resource. I mean, the better you manage your time, the more productive, the more efficient you are. Energy, that is a very big source of power. We were just discussing this at our consortium steering committee meeting a couple of weeks ago. A couple of prominent electric companies in Ohio, AEP and First Energy. They've got some old, outdated production facilities for electricity, and they were coming to the Public Utilities Commission of Ohio to ask them to approve a rate hike for them to cover costs of their adaptation or movement to more modern production. And the ramifications are there's going to be huge rate increases for their customers, starting at about 20-25% this summer, and then stair climbing for the next 4 or 5 years after that. Of course, industry is very concerned because they're big users of electricity, and that was a topic of discussion at our steering committee meeting. I still don't have my head wrapped around how this whole thing fits in, but we had a consultant who the chemical companies around Husky Refinery they've hired, and she was saying that the futures market for natural gas plays into this. I guess if you are using natural gas and buying that, and you pre-purchase this, and the market is very, very low right now, you're going to come out money ahead than if you were to buy it on the spot market and pay the higher price. And if you're using obsolete old methods of generating your electricity, and it's not natural gas, then you're getting behind the 8 ball and you're not producing things as efficiently. And anyhow, long story short, that's the foundation of their argument in trying to convince the PUCO to come up with a better idea of enabling the 2 power companies to adjust their rates and not just have such a draconian increase right out of the gate with consequential increases afterwards. Information is also a very important production resource, whether it be electronic or hard copy. It can come in many different forms, be delivered by courier, but information is another one of your production resources. The 8th and final resource, it's capital. Can't do much without it. Need it for cash flow, need it to pay for your labor, need it to pay for your materials, your utilities, and everything else. So yeah, that's something that we emphasize in our curriculum is the production resources. Have an understanding of at least what some of them are. When we test students in the career centers, they may not get as much exposure to that sort of thing, and they'll come up with some pretty wild answers, and none of them are even close to what this is. A production material. This is anything that's used to make another material or product. We're into process manufacturing. This is slide 15. This involves changing the nature of ingredients by applying heat or pressure, or mixing or separating by chemical reaction. There's discrete manufacturing. Discrete is something along the line. It could be assembly. It could be processes where materials are bent, cut, shaped, formed, but those are production processes. It falls under the category of discrete manufacturing. Another process of manufacturing, it's process manufacturing. Another process of manufacturing is process manufacturing. You see that a lot in your liquid materials. This is where you're treating something, you're changing the nature of the ingredient. You can do it by applying heat or mixing or separating, inducing a chemical reaction. We teach them what this sort of thing is. Another type of process in production is combined manufacturing. We have a lot of that here in West Central Ohio. Again, going back to a local example, Whirlpool, both the Ottawa and the Findlay plants, the Greenville plant, they do some combined manufacturing. They're doing multiple things in one facility. They might be doing some assembly. They actually have some process operating in their facility. Whenever you're doing painting and coating, that involves process operations. In producing an appliance, it could be under the category of combined manufacturing. Continuous production is just what its name would imply. It's when you're making the same thing continuously over an extended period of time. This reminds me of the tour that we had. Has anybody ever been up to, it used to be called Consolidated Biscuit, and now it's Hearthside Bakery. They call it the Cookie Factory up at Macomb. Very large company. I think they employ close to 1,000 people in Little Macomb, Ohio. But depending on who they're making things for, you'll just see conveyor belts as far as you can see making the same cracker, cookie, or anything. And that would be an example of continuous production, just making one thing consistently for an extended period of time. Custom production's on the other end of the spectrum. That might be something more in the line of producing jewelry. You might have a customized jewelry maker. You get into the high ends of the automotive market. That's something I've never been around, but you can have cars which are customized, made to specific orders. Interior, exterior, type of engine, performance of the engine, and so forth. And you've got casting and forming. Casting is associated more with metallic products, molding and forming more with plastics, and they're the same basic principles, although, like I said, one's more associated with metals, the other one more with plastics. Machining, we got a lot of that in West Central Ohio, and by machining, it could be use of a lathe, use of a mill, it could be CNC, anything that you take material and produce it into the finished product. Conditioning, we do have a local company which does that. Has anybody heard of Heat Treating Technologies? They're located on 4th Street, just off I-75. Their business is all about taking products that's produced by another company, and Unpreferred Manufacturing is one that comes to mind. They will produce parts to their farm implements, and they will ship those parts in baskets to Heat Treating Technologies. When Unpreferred produces these products, they might be a little too brittle, they might be a little too pliable, they need to be a lot sturdier and more rigid. So by heat treating them, you're going to be getting the desired characteristic. They'll actually go in propane furnaces and bake them, for lack of a better word, up to a certain temperature so that that metal is harder, more durable, and lasts longer for the implement that's going into it. So Heat Treating Technologies, that would be one example that comes to mind for conditioning. Finishing, I was talking about the appliance manufacturing sector. That's one example. Whirlpool, they would be putting the finish on their appliance that they're manufacturing. There's actually a company here in Lima. That's what they're all about, is coating, Metacoat. I'm sure most of you have heard of them. They've got facilities across the world. And the way they operate, they do have their standalone company here in Lima, but where a lot of their business is generated, they actually attach a separate facility to an existing company, like John Deere. John Deere will produce their tractors or implements, and then they get transported next door into the Metacoat facility, where they are, either they could be powder coated or traditional paint or whatever the coating might be. But we're pretty prominent in West Central Ohio in the finishing business as well. Assembling, of course, a lot of that, especially with the automotive, and there's several other places which deal with automotive, but assembly is one of the different processes of manufacturing. Separating, that's actually something within a company. Your chemical companies, again, like Husky, they do a lot of separating, and that's where your businesses to places like Potash and INEOS, Ford Amanda Specialties comes in. Husky's interested in taking the crude oil and making that into airline fuel or gasoline, but they've got byproducts which go to the other facilities on that campus. Potash will take some of that and produce it into commercial and agricultural fertilizers. Ashland Specialty Products will take the butane byproducts and make that into butane-idle. You got Linde Gas, they take the carbon dioxide and they make it into liquefied carbon dioxide and so forth. So separating, that's actually done here in Lima, in the Lima refinery. And then the other two, combining and filling. Where, as its name implies, you're actually blending ingredients together to make your finished product. And then, what you see there kind of reminds me of a soft drink company. You're putting the powdered product into a vat, and it gets blended into the soft drink that comes out at the Pepsi plant, for example. Story about that, they've got a box of material that actually goes into the production of one of the products that Pepsi produces. What's the lemon lime product that Pepsi produces? Sierra Mist. Yeah. Actually, a box of powder, and it gets blended in the vat. Eventually, gets produced into Sierra Mist. But you're talking about your hazardous material symbols. It was corrosive, and it was a level 3. And they said, "We're consuming this stuff." I can imagine that, if the stuff got exposed to water and left on the floor over a period of time, it would probably wear the concrete floor. And like I said, we're ingesting this stuff. Okay, properties of materials. This is another set of things that it's important for people to understand. You want certain materials for certain uses in certain situations, but it's good that they understand that there's a dozen different property materials. One of them is strength. How does it stand to stress, whether it's bending or interior stress, so forth. You want some things which are good for conducting electricity, or you want things that resist electricity. It's good to know what materials do what. Appearance, that's actually a property. How does it look? Do you want things to be smooth? Do you want things to be shiny? Do you want things to be a certain color? That's an appearance, or that's a property for materials. Brittleness, some things you actually do want to be brittle. Something that comes to mind, if you want a safety device, and if it's under a certain stress, it'll break it and it'll set off an alarm. So you want something that has a degree of brittleness. Or on the other end of the spectrum, you want it to be resistant, and you don't want it to break easily, so you want it to be very strong. Hardness, how well does it withstand penetration? We actually do have a stress tester, a tensile tester here at Rhodes State College to test, how well certain material does hold up. Ductility, how much can it be stretched before it breaks? Another material property. Malleability, how easily can you form it? How easily can you shape it? Elasticity, played with that just a minute ago with the rubber bands. One of you did not have a very elastic rubber band. How well can it return to its original shape when you stress it? Resistance to rust. Does it withstand environmental conditions? And then heat, conductivity, or resistance. Some things, I'm thinking of like cooking utensils. You want that to be conductive on the bottom where you're cooking, but you don't want it to be conductive on the handles. You want it to be more resistant. And then the melding point. Again, whatever you want, you want something that holds up under extreme heat or holds up under extreme cold. Good to understand the property. Flammability. What's the flash point of a certain thing? If you're going to be around a lot of volatile materials, and you're going to be exposed to flame or extreme heat, you don't want something that has a very low flash point. And we rushed you through there, but that's basically the module which covers the manufacturing process. Again, these first three are a little more theoretical. I mean, you're talking about understanding what I call the macro of manufacturing, just understanding the different processes, a little bit of safety. In the afternoon, what we're going to be doing is cover math. We're not going to go through a lot of math problems, but some of the things which historically give our students a lot of trouble, converting fractions to decimals and so forth, we've got a few little drills or a few little tricks to help them remember that. We're going to be getting out some measurement tools, give you a little hands-on demonstration of what the students would be exposed to when they're taking the class in terms of measuring things to the thousandths of an inch or measuring things within tolerances, things along that line. Any questions on what we've covered in either this module or the first three? We've got another exercise here that we have incorporated. If nothing else, we play games. Just take a sheet and pass it around. Just divide this up in two. Again, the whole idea behind these exercises is to foster thinking outside the box, seeing who emerges as a team leader, or how we communicate, things along that line. And this exercise will incorporate that as well. You see, we do have a wastebasket.
Yes, sir.
Okay. Okay, I see it now. Yeah, we're going to read the directions here. We're going to go back to our youthful inner self. We're going to make a paper airplane out of this exercise. And what I'm going to do is give you 2 minutes to take this sheet of paper, follow the directions, and then make a paper airplane, and then we're going to see who has the best airplane in terms of hitting a target. So read the directions. You'll make this airplane out of this sheet that you're holding, and we're going to, once you do that, we'll tell you when it's time to launch your airplane. And the person who can get it into the wastebasket, they will be declared the winner. If there are no winners in that, the ones closest will be declared the winner. You need to also give your plane a name. That way we can identify who our winner is. And put your name on it as well so we can give due credit. But I'll give you 2 minutes to put your airplane together, and we'll begin right now.